Hi students, welcome to my classroom. The topic for today's lesson is drift velocity. Now we'll begin with conductors. We know that conductors are those substances which allow electricity to pass through them. Assume that this is a conductor or a piece of copper conductor and it has lots of free electrons in it. Now these free electrons will be in a state of random motion. Now in this lesson we'll be considering two cases. We'll see how these free electrons behave when they are subjected to an electric field, and we'll also see how these free electrons behave when they are not subjected to an electric field. So first we'll see this. That is how the free electrons in a conductor would behave when there is no electric field. So case 1, a conductor without an electric field. So assume that this is a conductor and that it's having lots of free electrons in it. Now these free electrons will have thermal velocity and they will be in a state of random motion. Now due to this random motion, the average thermal velocity of electrons will be 0. So if we assume u1, u2, u3 to be the initial velocities, and if we assume that there are n number of electrons, then the average velocity will be u1 plus u2 plus u3 plus etc. up to un divided by n, and that will be equal to 0. Now why is this so? That's because the sum of these values, the sum of the velocities will be 0. Now why is the sum of the velocities 0? The sum of the velocities would be 0 because velocity is a vector quantity. And so if we assume one electron is moving in this direction with velocity u1 and another electron is moving in opposite direction with velocity u2, and if we assume that that the magnitude of these velocities are almost same, then the net velocity will be 0. They will get cancelled out because velocity is a vector quantity, so its direction matters. So we can say that the sum of these velocities will be 0. As the sum of velocities is 0, so the average velocity will also be 0. So we can say that for a conductor which is not provided with an electric field, the average thermal velocity of will be 0. The second case, that is a conductor is provided with an electric field. Assume that this is a conductor and it's connected to a battery. It's not that we take a piece of copper wire and connect it to a battery. This is just for us to understand the concept. So assume that we are connecting it to a battery so that there will be an electric field, and due to the presence of this electric field, one end of the conductor would become positively charged and the other end would become negative. Due to the presence of this positive and negative charges, the electrons within the conductor will start drifting towards the positive charge. If we assume these as electrons, these electrons would be drifting towards the positive terminal. That is, there will be a net velocity in this case. So initially we said that the net velocity of the electrons, of the free electrons in a conductor which is not subjected to an electric field was 0. Now the net velocity of electrons in a conductor which is subjected to an electric field will not be 0. There will be a net velocity. Let's check this in detail. Assume that this is a conductor and there are lots of free electrons in it. Now assume that we are providing an electric field E. Now due to the presence of this electric field, one end of the conductor would become positive and the other end would become negative. Now due to the presence of the positive and negative ends, the electrons within the conductor will start drifting towards the positive terminal. And the positive ions within this conductor, there will be positive ions in this conductor, but these positive ions would be attracted towards the negative terminal. But those ions will not move. They are immobile, they will not move. Only the free electrons would move inside a conductor. So as electrons move towards the positive end, they get accelerated. And as the electrons are moving in one direction, they will collide with the positively charged ions. So the electrons, as they start moving from this end towards the positive terminal, there will be ions, positive ions in between, and they will collide with the positive ions and thus lose a part of the extra velocity they have gained. The net result is that the electrons will be having a very small amount of final velocity. So in this case, electrons will have a final velocity. Whereas in the case of conductor without a battery, the net velocity was 0. That was because electrons were traveling in a random manner. Here the electrons would be traveling in one direction, and so in the same direction, and so the net velocity will not be 0. Now we've said that the net result is that we said that the electrons will have a very small amount of velocity. So each of these electrons will be having a very small amount of velocity. Now the average of these velocities is known as drift velocity. So drift velocity is the average of the small velocity with which they have which the electrons have acquired when subjected to an electric field. It is the average of the velocity which the electrons have acquired when subjected to an electric field. Or we can also state that it is the velocity with which the electrons get drifted towards the positive end of the applied electric field. We've said that electrons get accelerated. Electrons get accelerated means they have a gain in velocity. So we can use this equation, force is mass into acceleration. From this equation we can write acceleration as force by mass. Here we are considering mass of electron. And for force we substitute it with charge into electric field. So here we are considering electrons. So for charge we substitute it with minus E. So that acceleration becomes this. So we get acceleration of an electron as charge by mass ratio of an electron into electric field. Now after collision, velocity of an electron becomes v1 equal to u1 plus a21. Now we got this equation from this relation. So we get the final velocity of an electron is equal to v1 is equal to u1 plus a21. Here v1 is the final velocity, u is the initial velocity, a is the acceleration, and τ is the time taken by the electrons to collide with positive ion. After collision, velocity of electron becomes v1, of a second electron becomes v2, of a third electron becomes v3. Now we've said that drift velocity is the average of these velocities. So we'll calculate the average of v1, v2 and v3. The average of these velocities will be v1 plus v2 plus v3 plus etc. up to vn divided by n, where n would be the number of electrons. Now substituting for v with u plus a2, we get the equation like this. Now from this equation we take all the u terms together and the τ terms together, so that the equation becomes like this. Now we've said that this term u1 plus u2 plus u3 plus etc. up to un divided by n is 0. That's because the electrons would be moving in a random manner initially. So this average velocity, initial average velocity would be 0. So we can substitute it with 0, and we will assume τ1 plus τ2 plus average of these τ is τ. So we get the equation for drift velocity as acceleration into τ, and for acceleration we substitute it with small letter e into capital E by mass of electron, that is charge by mass ratio of electron into electric field, and we get the equation for drift velocity as charge by mass ratio of electron into electric field into relaxation. Next is mobility of an electron. So mobility of an electron is the drift velocity of an electron. Mobility of an electron is the drift velocity of an electron for a unit electric field, and it's represented by the symbol mu. It is drift velocity by electric field, and to calculate its SI unit, we know the SI unit of drift velocity is meter per seconds and the SI unit of electric field is volt per meter, so that we get the SI unit of mobility as meter square per volt second, and mobility is a scalar quantity. Now let's have a quick glance at what we've learnt. We've seen that drift velocity is the average velocity attained by free electrons in a material due to electric field. It's represented by Vd. It is equal to charge by mass ratio of electron into electric field into τ. It is in the direction opposite to the electric field for electrons. Drift velocity SI unit is meter per seconds because it is velocity and it's a vector quantity. Mobility of an electron is the drift velocity of an electron for a unit electric field. That's all about drift velocity and mobility. Thank you for watching.